fat. It is probably the most important thing because everything starts at the digestion. So again, the world of fats is complex and there's a lot of structural fats that we need. And I'm going to go over the bile acids today, of course, and some steroid hormones. So without fats, we really have nothing. And the reason is because our cell membranes are basically all fat. The cell membrane is what keeps your cell alive, intact. It controls what goes in and out. And there's over 20 million fat molecules in your cells versus only 2 to 3 million proteins. So we always pay attention to DNA and protein, but it's really the fat that keeps us alive, separates the outside from the inside of the cell. So um, how do we digest fats is actually very, very complex. That's why I made this talk and always wanted to emphasize that you have to take your balance oil with a big meal and that you are able to digest fats. And part of the reason why it takes so long to get balanced is because we don't digest it. And if the state of our epithelial lining in your gut is not proper, then we are just wasting everything we're eating. Um, my uplink always says, uh, you basically can throw away $80 from your $100 bill that you spend at the market. You're just not absorbing it. It just goes right through, and obviously that's the case with all supplements. So today you're going to find out how omega-3 actually changes that. So what are the steps of absorbing fat? First, you are hydrolyzing a little bit of your fat in your mouth and in your stomach. That's a really small part, but it is important in early years. Then you have to emulsify the fat, basically package it into micelles that are actually soluble. And those micelles contain bile. And we know that basically are essential to digest your fat. Then these micelles have to be absorbed into your intestinal mucosa. Then they get shuttled into chylomicrons, and that goes into the lymph and circulates through your body, and finally ends up where it needs to go into your cells. So it's a very complex process, and I will go through that today. So I borrowed a few slides here from another YouTube that I will give credit at the end. But essentially, in your mouth, you are starting to digest fat from lingual lipase. That actually gets secreted from your tongue, believe it or not, but only very, very little. So only 15% starts to get digested. And the reason we have that is part of the reason we need to actually sense how much fat we're eating to make us saturated and to give the body a feedback that we're not overeating. And the other part is that when you're an infant and when you're young, your bile action just doesn't work yet. And that's how they absorb fat. The next step then is basically your chief cells in your stomach. And they also secrete a lipase to digest your triglycerides. So basically separating the fatty acids from the glycerol is the key of digestion because glycerol is soluble, fatty acids are soluble, but triglycerides are not. Fat swims on water, it's not mixable. So that's why this complicated enzyme digestion is needed. So again, both the tongue and your stomach actually secrete some enzyme, but it's very, very little to digest it. And that mixture of fatty acids and cholesterol and vitamin D and so on is basically floating in the stomach and gets further emulsified. I am definitely looking out for people that still need to join. So bear with me. So when all of that ends up in your stomach, the next step is the most important one. Well, let me talk about fat taste receptors first. So how do we get a feedback that we're actually eating enough fat, that we're eating enough calories, and that is on your tongue, oral sensing, free fatty acid receptors. And that all gets mixed into the whole Ozempic discussion, GLP-1, the hottest drug on the market right now. So there are receptors on your tongue, GPCRs, and these receptors I will be talking about in a little bit and how they intertwine with omega-3. And they are basically telling your body you are eating good calories, you're getting full. We all know about leptin, comes back from the adipocytes. That is a very slow process. So the first process really is those receptors on your tongue. And then you're getting your dopamine reward that this is energy dense food, and that activates brain sensing. So it's very important that we have fatty acids digested early, so we are getting that feedback. So the most important part of digesting fat happens after the stomach in the duodenum, where it all comes together, the pancreatic juices and the liver bile juices. And this happens at the so-called enteroendocrine cells. So other than these chief cells in the stomach, these have a completely different function. They're actually real sensors. And as you will see very shortly here, that these EECs 100% require omega-3 to actually digest fat and omega-3. So there's a feedback mechanism. There's a cycle here that is absolutely important. So these EECs, they sit literally on the cell wall just before the bile duct on the duodenum. And these cells are extremely important to digest fat. So when you are activating these cells, so when some fat starts to bind to it and when omega-3 binds to it, you're making cholecystokinin, which literally rules everything. All of these processes of releasing bile and pancreatic juices. It's the most important um, hormone peptide. So just like GLP-1, it's a small peptide that literally activates the whole process. So again, if your EECs aren't working, you're not going to release that important CCK peptide that will activate everything else. So only when you release bile and pancreatic juices together, you can really start digesting the other 85% of your fat. And so that is basically, again, what it does. So gallbladder contraction, pancreatic enzyme secretion, and it slows down your stomach emptying because you want time to digest your food. You want it to be sitting in the stomach for as long as possible, so you're pre-emulsifying everything, and it is very important to not just empty everything straight into the duodenum. So again, omega-3 fatty acids are probably the most potent stimulator of this enzyme CCK, I mean this peptide CCK, um, and that is absolutely required for everything, gallbladder emptying, and the cholesterol, which I will be talking here very shortly. Reminder that bile is made from cholesterol. That's why it is the second most important molecule. It is extremely important, and I'll be talking about the narrative about bad and good cholesterol very shortly here. So it is known to everybody that when you eat fat, you release bile, but I just showed you that that is not a trivial process by any means. And so converting bile acids from cholesterol requires enzymes, and there are definitely very important steps that need to happen for the bile to be made. And then that is so important, this bile, that the liver actually recycles 95% of it. Only 5% gets secreted. So the liver basically contains cholesterol. It has a huge amount of storage of cholesterol. If you don't eat cholesterol, you have to make it. It is a very, very costly process, and that's what statins inhibit. So if you don't have enough cholesterol, your body needs to make it. It's absolutely essential, and it's a very energy high process. That's why vegans are basically very thin and emaciated, because it takes away all your energy. So out of the cholesterol, which is not really polar, it's not soluble, it can't dissolve the fat, you make a bipolar bile acid. So it has charged groups on both sides, which you see here on red, red. And then they usually form other attachments. These are very soluble molecules, but they are ultimately derived from cholesterol. And so then, they can naturally dissolve fat. And so once your liver is basically in a state of having a very good bile action after your enterocells are activated, fat absorption can happen, and you make those micelles, and those micelles then, like I said, eventually end up in your large intestines and in your lymph system, and I will go over that here shortly. So what the point here is that pretty much all of your digestive products, after they are absorbed in your intestines, have to go through the hepatoportal vein. So most people don't know that. Literally just one vein that backfeeds from your digestion into your liver, and everything needs to go through that with a few exceptions. And that is the name of the game. So if you can't absorb and your liver can't uptake the nutrients, you really have nothing. So the molecules that don't go through this hepatoportal vein are actually omega-3. So all long chain fatty acids need to go through the chylomicrons. We are the lymph system, which then drains into your vena cava and gets back to the liver that way. So most fat-soluble vitamins, A, D, E, and K, are also absorbed through the lymph system, so very important. Yeah, so only 5% of the bile is excreted through your stool, and again, if you are not eating cholesterol, you have to make it. About 1 gram per day is required, and that is a very costly process. So it's actually very important to eat cholesterol. And at any given time, an 90 kilogram male has close to 800 grams of cholesterol in their body. So it is the second most important molecule after omega-3. So what happens if you had gallbladder surgery? Basically, you are turning on a light switch and there's no bulb connected. So there's no more storage of bile, yet, the bile still needs to be released from the liver. So if that CCK peptide that starts all of this digestion gets activated, but there's no surge of bile, you're basically diluting continuously. You have a trickle, and you are basically not really able to have a good backfeed on your fat digestion. So it is very important to have a gallbladder. If you don't have it, you are actually in trouble, not only because you're missing a large amount of bile, but you're also basically in a state where you can't regulate the whole digestion. So that's why we're talking about Aqua X today and how we can trick the soul system. So when you don't absorb fat, you get fatty stools, and that is not a good state. It goes right through basically, and you lose a lot of fat for energy. Um, and there's a very important feedback through your liver that you don't have, and you're actually losing cholesterol through that. So, digesting fats, I don't have to tell you that again is very, very important, especially also because of the fat-soluble vitamin A, D, E, and K. So we're all vitamin D deficient. That's why we take Xenoshine, and that is basically not absorbed without that. So how does this work again? So you have that globule of pre-digested fat in your stomach, but it's not really digested. Only through bile action, you're forming these micelles, and that is a real packaged large molecule. I'll show a picture of that later. So that actually can really be floating soluble in your digestive juices or digestive tract and can then be absorbed passively or actively into your gut. So it's very important that you form those micelles. For that, you require bile salts. Otherwise, it's not going to get into your epithelial cells. And that is the name of the game. So the gut-brain axis can simply actually be explained by omega-3 modulating these entero cells that I mentioned, EEC cells that sense omega-3, sense fat early on in your duodenum. And ultimately, when you don't have that proper function of these EEC cells, these switch cells, basically, it affects everything, including your gut-brain axis. I explained in the beginning how getting free fatty acids back on your receptors then ultimately affects everything in your brain sensing abilities of regulating appetite and satiety. But of course, we know this has a lot to do with inflammation and leaky gut. So when you have a 30-to-1 inflammatory index, you are basically in a state of very high inflammation in your gut, and that breaks down the epithelial cells. And I talked about that many times in other talks, and that's really not anything new. So we have omega-3 fatty acids that directly bind to these receptors, GPCRs and CD receptors on top of these EECs. And that is real hard science. So if you don't have omega-3, you're not activating these receptors. You're not going to get a good fat digestion. You're not going to get satiety. You're not going to get a good brain access, period. So omega-3 pathway is again through these receptors on your cells, a very important receptor. It's a topic on its own. It's actually a similar receptor than your rhodopsin in your eye. There's a whole class of them that regulates pretty much everything on your cells. So yeah, anti-inflammatory pathways are triggered when you have omega-3 and they can bind to that receptor. And then we get into the whole GLP-1. So why take GLP-1 in a very dangerous drug form if you can actually naturally activate it with omega-3? Again, that triggers the other peptide, the CCK, which digests fat. So the whole thing activates insulin secretion, and the whole process is balanced in itself if you have omega-3 present in your fat. Yeah, I am already mentioning this, but what I didn't mention, of course, is the gut-brain axis works on serotonin, and that also gets affected by these EEC cells, but only if you have omega-3. And that then back feeds also into your gut mobility. And that's how you create the gut-brain axis. So yeah, when you don't have omega-3, which most people don't, right? We're 90% deficient. Then you have a state where you're in continuous inflammation, and that has many effects. It reduces membrane fluidity. That's why we have that on our test. And you're actually not even able to express those receptors that create the satiety. And you're actually not able to really make bile, and then you're not able to make micelles, then they can't be absorbed. So all of that in the end contributes to their gut inflammation. And it gets way more complicated. Omega-3 does so many different things other than inflammation, but that's basically the vicious cycle that you are creating here. So finally, after we've made our micelles, we can absorb them. They go actually passively into your enterocytes because they're already able to fuse with the membrane. So again, without that micelle formation, you can't absorb them. And then they get actually broken down again and reassembled again into those chylomicrons. And the reason for that is that in the end, you want to have a good mixture of all different types of fats, saturated and omega-3, omega-6, that gets delivered to the whole body. So basically, all the fats get reassembled into those chylomicrons. I'll show you a better picture later. And then there's receptors on those. And that's the same thing as the LDLs and HDLs, kind of a shuttle through your body. But after these are made in these enterocells, so very important cell again. So your gut cell, the first cell that absorbs fat, has to make these chylomicrons. Very complicated process, because those then get absorbed into the lymph system, and that lymph system spreads through the whole body, goes back to your vena cava, back to the liver, and into every cell. And that's again what that CCK peptide is doing. So chylomicrons are made in a very, very complicated process inside those enterocytes. So after the micelles are absorbed, they get taken apart, and then you have to assemble those chylomicrons. I'm not going to go through those details, but there are apparatuses inside the cell, namely the endoplasmatic reticulum and the Golgi, which basically are involved in this process. So you need a very healthy enterocyte in your gut to actually go through this process. And then again, so part of the whole deal here is that these chylomicrons are actually marked with receptors, so they know where they're going to go in the body. Yeah, so here's a summary once again. So you need to make micelles. For that, you need these EECs, you need omega-3, then bile salts, and then the micelles are actually also responsible in part for the fluidity of the microvilli. So there's a lot of surface on those enterocytes, the villi. And without omega-3, the micelles directly contribute to that flexibility and to that fluidity. So that is a passive process, and there's transporters involved, and you need cholesterol for that as well. Then the fats are actually, after they've been broken down, right, with lipase and and the bile in the pancreatic juices. They're now actually reassembled back into triglycerides and then packaged into those chylomicrons, and then they can enter the lymph vessel and go through. So those are all the steps. A lot of steps. Most people don't know how complicated this is. So that's why you always want to take your omega-3 with a big meal. And finally, when they do travel through your body, through the lymph system, they get targeted by these receptors, APO receptors. I'll have another picture here shortly. And then, they know where to go. So we want to put triglycerides into adipose cells. We want to have cells, muscle cells need energy for fatty acid oxidation. So the brain does not intake chylomicrons. It actually has to get DHA versus a completely different process. And also the kidney is compromised here. So kidney is the only organ you can't really fix once it's damaged to a significant amount. It's irreparable. And then you have all kinds of metabolic syndrome problems. So this whole process of absorbing fat and omega-3 is extremely important when it comes to the brain and the kidney to keep them healthy. So here's a picture of these different organelles floating in your lymph system. So the chylomicrons that I just talked about assembled in your enterocytes are huge. And then you have your other cholesterol particles, which really they aren't. They're just fat particles floating through your blood. And they have different purposes. So LDLs basically coming back from your system into your liver, they get recycled. And it's pure coincidence that there is cholesterol in these plaques. There is no good or bad cholesterol. It's all explained on my website, omega3health.us. And LDLs have to have more cholesterol than HDLs for a very specific reason. And that's literally why you find those cells in the plaques. But the plaque is inflammation. I always say you have a pile up on the freeway, which you're going to find a bunch of cars, right, in that pile up, but it's not the car's fault, it's the driver's fault. So that's what was one of the biggest misconceptions ever invented. Cholesterol is pure coincidence. There is no good or bad cholesterol. And you have to have massive amounts of cholesterol. That's why your body recycles it into the liver, because it is such a costly molecule to make if you don't eat it.
Amen.
Yeah. Okay. Last but not least, we circumvent this whole process with our Aqua X. So it's a new technology, fairly new Aqua Cell. You can look that up, aquacell.com. Genius step. So when you are basically ingesting normal balanced oil, the absorption is minimal compared to the Aqua X. Mainly because we're circumventing that whole process of the bile, right? And so I'm putting everybody on Aquacell now. I think like 4 out of 5 new customers are all on Aqua X. And they like it. It's only $7 more, and you basically get record speed. So I got this from Birgit C, actually a German. She actually had that first data on this. So by any means, first Aqua X, then everything else. So it's not just about people who don't have a gallbladder or who can't digest it. Put everybody on Aqua X for the first few months. And that is basically all I have to say about that. Naturally, that Aquacell technology is natural. So it is described on their website and on our website, a pre-emulsifier, and you have a high bioavailability, right? That's what it's all about, bioavailability. And then once you're balanced with omega-3, everything will be bioavailable because your enterocytes can actually function properly. Awesome. Yeah. So that's all I have to say today. Here are my credits for the YouTubes. And there's plenty of YouTubes out there if you have more questions about how to digest anything. So, any questions I can answer? I definitely finished on time today. Sometimes it's a little bit longer. Hope you
Mhm.
guys had fun and come back next time.
But I'm just gonna ask you something. You said something about take the supplements like omega-3 together with dinner.
Mm-hmm.
So that's because I heard to take that it's gonna be taken before nighttime. Is that wrong?
So,
Like,
um, I highly discourage from taking any supplements, period. Any supplements without food. When your
okay,
digestion is rolling, you are basically in a state of active
okay,
absorption. So, I have a few people who are early risers and they can take omega-3 in the morning. But if you're just going to take straight up balance oil first thing in the morning, you're just going to get heartburn. And
okay.
so we have our trick with the shot glass. You guys know all about that, right? 50-50
Yeah.
water. That
Mm-hmm.
way you don't coat your throat and the whole thing goes through.
Mm-hmm.
But
Yeah.
still, you need to be able to absorb it. So, whatever big meal you're eating, if you're an early riser and you're eating a big breakfast,
Mm-hmm.
if you are a big lunch eater, but definitely not before you go to bed.
Okay. And does it matter if it's in the morning or afternoon?
I think there may be some data that you're able to absorb omega-3 a little earlier in the day. So late eating in general is not a good idea because you're just taking a long time to digest overnight. So the earlier you eat your fat, the better. But in any case, you have a very good state of digestion midday, I would say. But dinner, most people eat dinner. I mean, it's just what it is, as long as you eat it before 6, 7. So, I mean, I don't
Okay.
know. I mean, there are cultures, Spanish culture, right? They eat their fatty barbecue at 10 p.m., right? So, it's different for everybody, what you're used to, what your food habits are. But again, you need food.
Mm-hmm. Okay.
Awesome. Yeah, great question. Any other questions?
Yeah, I heard that you talked about the cholesterol.
Yeah.
I didn't catch everything of it, but as I understood, there's no bad cholesterol. I think the same way. That's why I said amen. But so that is what you say too, like um, yeah, like it depends on the triglycerider.
It depends on what?
The triglycerider. I put an accent on it. Triglycerider. I don't know how to say that.
Triglycerides?
Yes.
Exactly. So if you go to my website, Omega-3 Health,
Mm-hmm.
you basically find a huge section there on both triglycerides and omega-3
Mm-hmm.
and cholesterol. So again, I don't want to say it, but it's the biggest narrative ever invented.
Mm-hmm.
So there is no evidence that statins prevent heart disease or stroke.
Mm-hmm. No,
Uh,
I found it myself. I found it
that's
up myself reading science.
Yeah. So when you have high triglycerides
Uh-huh.
in a state of metabolic syndrome, and you're basically in a state of a very, very difficult situation where
Mm-hmm.
you are thinking you are starving. And so
Mm-hmm.
that's what diabetes is.
Mm-hmm.
And that's why triglycerides are high. And the details of how omega-3 downregulates triglycerides are on my website. And I already
Mm-hmm.
talked about that on other talks. Basically, um, it doesn't take a genius to understand that, high triglycerides
Mm-hmm.
means your body is in a very bad metabolic state. And
Mm-hmm.
we are going down to the 30s now, right? When you're
Mm-hmm.
balanced, that's like unheard of. Um,
Yeah.
and that's how you know this works.
Mm-hmm. Yeah, I got low. I got low triglycerides. They are
Yeah,
low. They are very low.
yeah,
But the LDL is pretty high.
yeah.
So, but it's yeah, so the cholesterol is high, but it doesn't scare me much.
High cholesterol is good. So,
Yeah, that's what I see too. I will live longer as I have a high
so
cholesterol.
I've talked about this on other talks. It's
Yeah.
anything below 160, your mortality rate goes up 2.5 times.
Hmm. Yeah,
Awesome.
good. All right, thank